For the last 5 years, I've been leading the business for telco at AWS. And we've done a lot of good stuff, moving a lot of cores to the cloud, building the dishes network here, which, it's a little bit of a competition to you guys, but not much at this point. We've deployed the first RAN in the cloud with NTT Docomo and so on. But over the last 2 years, it's all been about generative AI. It really, really took off for us. So while data is the topic, I do want to share a few observations of what AWS has been seeing in the space. So when I first started engaging in this space 2.5 years ago, there were 34 models on Hugging Face. Yeah, any guess how many models there are now? Last, yeah.
Oh, Hugging Face is huge.
There are 380,000. From 34 to 380,000. There are industry-specific LLMs. There are large action models. And we established this strategy, which has always been AWS strategy of choice, which is what we brought to when we said we're not going to own our core, we're not going to own our RAN. We're just going to be the best place to run your core and RAN if you go with a hyperscaler. And it's the same strategy that we used when we entered into the Gen AI space. We want to be the best place to train your model, to host your model, and in the future, now, inference on it. So, and then, how are things going in the Gen AI space for telcos? 2023, we ran 1,900 POCs. $1,899 of them did not go into production. I exaggerate a bit, but very few. But now, they are going into production. I will talk a little bit about what is going into production and what's not. The obvious one is the whole customer care. It is obvious, post-call analytics, live call analytics, agent support, agent assist. All of that stuff is, I think it's pretty much a fait accompli at this point in terms of it will be embedded in the customer service aspect of it. But what's super interesting right now is while you have all of those assistance tools that have been deployed, the next step is the large action models and the agents. One telco that we worked with had documented, similar to that flowchart that Ravi showed, almost 1,500 standard processes that they were running manually. Every single one of those is agentifiable. There'll still be, like Ravi mentioned again, a human in the loop. But we are starting to see about a 90% efficiency improvement in those, in agentification. The other thing that is happening at scale is, and maybe it's next year, if I were to really think about it, the collapse of the NOC and the customer-facing service people into the same environment. There is no reason you shouldn't have an end-to-end view. Like today, if there's an issue with the network, the customer-facing call center hands it over to a NOC and there's like a whole resolution pattern. But with something like what he demonstrated, which is a natural language query, why can't someone who's not even familiar with RF query the network inventory, the network performance, and unite the NOC and the customer operations into the same one? So there's a lot of trials going on that front, which is huge savings because I was with a European customer who was saying that they were spending $1 billion on each. it's obvious where the savings are going to come from. The third one was network observability, RCA, automated resolution. Now, I think what you'll see in a month from us at reInvent is the first use cases of that in production, but in very controlled circumstances. Next year, you're going to start seeing more of that in terms of actual deployments. Finally, inference. We've spent 2 years training a significant portion of those 350,000 models that I talked about. But now, the next wave is going to be inference. Training will continue to happen, and we've said publicly that we think there's probably going to be about 10 large LLM suppliers that essentially own the market. We intend to be one of them. We've said that publicly. You know who the others are. And the OSS guys are coming up very strong in the LLM space as well. So we're absolutely convinced there's going to be 10 of these, but there's going to be multiple fine-tuned models. But RAG is really the predominant mode that these are getting deployed at this point. There's a lot of issues with training models and keeping them in production in terms of cost, as I think you and I talked about as well. So that's roughly what's happening out in the industry. It's all about, we're going to get into the era of slow reasoning. Right now, we're talking about instantaneous results. That's actually not how a human operates. We think before we reply. That's how a computer operates. So, slow reasoning, where you're actually mimicking a real human in deployment, is where we're headed for more complex business problems. That flowchart you showed, that's probably one layer out of 1,000 layers of what a human actually really thinks about when they go through this. And that's where we're headed. There are more than 1 million agents out there now for different industries built on those models. So we're going to have to find a way to do multi-agent orchestration, where agents talk to agents and then create actions with large action models. And then who governs all of this? That's really where the battleground is going to be. What is the governance mechanism? And so any questions on what we're seeing in this space as we go forward?
Okay.
Obviously, so I actually adapted my talk because you guys know this stuff. Okay. So when we talked about the unified operations center, these are the data silos that we've had to go integrate across multiple telcos. Not across multiple, within a large telco, across multiple silos. And obviously there's a lot of this stuff here. But the takeaway here is basically now is the time that these are getting unified into a single architecture. Our position is that you are missing the full power of generative AI if all of this data is not available to be RAG'd against, or if you choose to fine-tune your model, to fine-tune the model with. Because you can't really diagnose a problem if you don't have access to all of these data sets. So one of the people who have done this successfully, and we've talked about it publicly, is SKT. So they've fine-tuned Claude 3 with their set of data. Every single one of these went into what they're going to call TelClaude. And they're seeing about a 99.3% accuracy rate at this point. There's multiple metrics. As you know, no one's standardized on a metric. But they're very happy with what they're seeing, and they'll demonstrate these results live. But they're using it today in production. SKT. Right? They're the first ones who did this, but almost every large telco is actually doing something similar. There's variations on a theme, but that is the theme. Taking one of the available models, tuning it. The other thing that's happening is they're starting to deploy small language models for asynchronous customer support. If you look at what we announced with TELUS, which is the one thing I can talk about publicly because we publicly announced it, they actually have an asynchronous agent sitting on the phone. So you can actually talk with the agent itself. And then it requires a whole new different data structure as to what data is available locally, is synchronized, and what is actually going to be sent to the cloud. Okay, so that's one. The other one is, if you look at what Deutsche did on their Magenta Moments app, they've actually integrated an agent into Magenta Moments, which is the equivalent of T-Life, right, in T-Mobile. So you can actually go in there now, and there is a Gen AI button in Europe that you can ask for help. And there are other telcos actually deploying stuff onto set-top boxes, onto connected cars, so on. So there is a disaggregation also of the data going, like which portion of the data actually gets replicated, how often, and so on. So why are we working with people like Aira? So right now, what's happening is the whole customer service aspect of it is getting revolutionized. Hopefully, we'll get to a unified operations center at some point in time. I still think it's going to take 2 to 3 years to get to that unified operations center, but the savings are massive. The thing that excited me most was, I know it's a little immature at this point, but the app builder, right? You have reams of this data internally. I've seen it. How to do architectural drawings for the city of Irvine where I live. That is a standard procedure. That is an agent. It is not 100 people sitting in a dark room doing CAD drawings. It is maybe 10 people checking the 1,000 drawings that have already been generated based on the RF planning that's already been generated. That is the future. That is what we're saying. It is an augmentation of productivity. It is an upskilling of people who've been doing the undifferentiated heavy lifting. And again, we will start seeing that get implemented at scale. So one of the things you got to figure out on your data strategy is, are you going to be RAG only? Because I know one of the telcos in the US is RAG only. They've made that statement very clear. Some of them are fine-tuning their own LLM. SKT is doing it. Etisalat is doing it, for example. And there's a very interesting trend on the fine-tuning side, which is maybe not as applicable in the United States, but it is super applicable in every other country. We've announced, for example, with FastWeb in Italy, that in cooperation with the Italian government, we're going to fine-tune an Italian LLM that is actually going to serve the citizenry of Italy with all of the government data that's available. Like what is the taxation rate here? I mean, what new regulations do I need to worry about if I move from this city to this city? What houses are available? What's my who do I need to reach out to with this problem? So the telcos are becoming that conduit in the rest of the world because they're a trusted source. In most countries, it's a quasi-governmental organization, not so much in the United States. And so those partnerships are really taking off, where you have either a language or a cultural issue. With Omantel, for example, they are building an Arabic LLM because culturally, the answers they were getting from a Western trained LLM was not really amenable or applicable to the Middle East, as you can imagine. So they do, and these LLMs are becoming a concern for national security as well as a sovereignty issue, pretty much worldwide. So almost every other country has a national LLM going, except for the United States for obvious reasons. And even Canada has one going, right? I don't know how they're that different. Huh? A? It says A all the time, so. So hopefully, I don't want to take too much time, but hopefully just want to give you a quick overview of what we're seeing.
When you could talk a little bit more about the large action models.
So the large action model is actually, so I'll use an example. There is today a Salesforce agent, I forgot its name, an Agentforce agent that will actually, you can actually program it to operate a computer, to write a customer service email and send it, or to actually, so let's say you want to reboot the Wi-Fi in your house. The large action model will actually reboot the Wi-Fi in your house without a person doing it for you. It actually takes that action automatically.
It's like what we think about closed loop automation.
Correct, exactly. But it's reasoned, it's right. So that's what a large action model is. But it also monitors what's going on and reasons it out. If it didn't work, it has the ability to try different things and actually go through all of that.
You're more about us.
No, it is being deployed today. It is not a concept by any means. But the way it's being deployed is a little slower than an LLM because it's an actual physical activation. So in most cases, there is a human supervising it today.
Because it's making a real action.
Correct.
Not just
Correct.
generating things.
Correct. Today, but as you collect more data and you see what the error rate is, at some point that is going to start backing off because it is being reinforced with what the human is seeing. So at some point it is going to asymptotically tap out. Let's say it's good enough. It's better than human error. That's the threshold. And human error is pretty high. Right? So that's what we're saying. So hopefully that addresses things.